All right. You're officially welcome to another PLD session where we are discussing object-oriented programming in Python. And as we do always, I'd always want to build up from something new and grow it to the point where you don't know or you know it but need clarification on. So bear with me as I start from like the very basis to build up your knowledge on object-oriented programming. Hi, does it kindly mute yourself? I'm getting feedback from your end, so kindly mute. Then, if you want to make a contribution or ask a question, then you're mute. All right. So when we talk about object-oriented programming, the first thing that we want to look at is what is it at all? What is object-oriented programming? And if you have ever done any sort of reading around it, you would come to appreciate that this is just one of the many paradigms of programming. My pen, paradigms of programming. That is like it's a way of programming. So there are different ways that you can approach your programming, but then this is one of the commonly used programming ways or paradigms that we follow. And there are even programming languages that are totally object-oriented programming. So we tend to call them mostly OOP. So you find a language like Java is purely OOP. So it doesn't follow the other paradigms. It rather follows object-oriented programming. We are working in Python, and fortunately for us, Python supports the other programming paradigms. So we've been working with the others for some time now, and now we are moving towards object-oriented programming. And this is very important because with this kind of way of programming, it helps us model our software or the applications that we write. We model them after real life, let's say, objects, like real life things that you may come across. Okay, so the concept of object, anytime you say objects, like think about it. If I ask you which object are you using to join this session now, you should be able to tell me whether you are using a phone, a laptop, or any other alternative connected to the internet to join this session or watch this lesson. So that is an object. So that kind of concept, we want to be able to represent our software or part of our software in those kinds of concepts, like model them after real life objects. How do we do that? So this is where we go from. Let's use an example. Car making process. Let's say a company like Tesla. Tesla makes cars. Cars are objects, okay? But then Tesla didn't just get up and say, hey, we are making a car, and just go and pick anything at all and put it together and made a car. Obviously, they would have sat down, thought about it. Okay, we want to make a car. How do we want our car to look like? Eventually, what Tesla is going to do is to be able to come up with what we'll refer to as a blueprint. Okay? In the same way, if somebody wants to build a house, you don't just get up and build a house. Let's say an estate wants to, a very big estate, they want to build various houses inside the estate. They don't just come and put cement and things together, but then they start with a plan. And you realize that we have a plan that we are going to use to build, let's say, all the houses in there. So that plan or a blueprint, depending on where you are, the angle you are looking at this whole thing. If you're building a car, what you come up with, you can call it a blueprint, you can call it a plan, whatever you want to call it. Then in other cases too, we can say it is even just what? A template, based on which we are going to look to build the other cars that we are going to build, or build the other houses that we are going to build. So in programming, if we want to do something similar, which is what we do in object-oriented programming, we also have to come up with a template as such that we are going to be using to create the individual objects. So if Tesla is going to, so this is representing Tesla, which is having a blueprint to be making their vehicles. Then this is representing an estate that has a plan to build their various houses in a given estate. So for Tesla, let's say Tesla in a year is going to make, say, 2,000 cars. Let's assume that they are going to make 2,000 cars. For them to make these 2,000 cars, they will definitely have the blueprints laid down. Then they will now go and take the blueprints and say, okay, so anytime we want to make one of these cars, this is what we need to do. These are the number of parts that we need. We need to bring this bonnet. We need to bring this engine. We need to bring this, because everything is stipulated inside the blueprint. Then based on the blueprint, we are able to build the car that performs particular functions. I mean, we all know the function that the car performs, but then I am just mentioning it so that we are aware that whatever we are creating out of this blueprint has a function to play. Okay, it has some form of function, or what we refer to as some form of behavior. If you make a car out of this blueprint, and this car, we know that cars are supposed to be able to move. So if you end up making a car from this blueprint and the car doesn't move, then you didn't achieve what the blueprint gave you to achieve. Okay, in the same way, the car too has some properties. Okay, so for instance, we can say, oh, this car has 2 lights, 4 lights, 4 wheels, like all those things are properties. So let's bring this whole concept into programming. And why did I even go that route to mention these things? I said earlier, usually you have to start from something that you know, and I believe this is a concept that we all appreciate. So in object-oriented programming, we have a concept called class or classes. And basically what a class is that blueprint or template or plan based on which you use to build any object that you want to build. So if you want to represent Tesla's blueprint in terms of code, so that you are going to use your code to model Tesla building cars, then you are going to create a class. And this class, what this class is responsible or supposed to be doing is this class is supposed to serve as what? The blueprint. It's supposed to serve as the blueprint based on which you are going to be building your cars. Chuku, kindly mute yourself if you are not going to contribute, okay? So that I'm getting some feedback. Okay. Still, how you go, Chuku? Otherwise, I would have to mute you from here. Okay, good. Thank you. So the class that you are going to create in your programming language is basically that template that we are going to base on to create other cars, okay, cars with this nature. So that is what we call a class, basically. Then from this template, we are going to be building cars. So now when we come, we take the template. The template gives us the blueprints. It gives us all the things we need to build the cars. So today, let's say today, the engineering team has been tasked to build 20 cars. They are going to base on this template to build the cars, right? So if they build car 1, car 1 was built based on the templates or the blueprint that is provided here. We call car 1 in object-oriented programming, we call car 1 an object. So an object is basically that particular thing that you were able to create from the blueprint that you were given. And in programming, the blueprint is called a class. So anytime you are able to create something out of the class that you were given, you say you have created an object. We'll look at the implementation in Python, but then I need you to understand the concept before we go to how these things are implemented. So in simple terms, all that I've said is you are always going to create like a template of things or a blueprint for things that you want to model. In our example right now, we're using what? Class. We are using Tesla building cars. So we have created a class which is basically a blueprint for creating these cars. Then based on this blueprint, we gave the engineering team, hey, I want you to build cars based on these blueprints that I've given you. Or if you are using the building for an example, you can say the plan that the architect gave you. Go and give it to whoever is in charge. Is it construction workers or masons, whoever is in charge. Give them the plan and tell them, I want you to build a house according to this plan. So when they start building, they build the first house, call it house 1. They build house 2. And any of these that they are building is based on the plan that the architect made. These set of houses that are being built are referred to as objects. Okay, so this is also an object. And these objects are derived from what? The class. I hope those two concepts now make sense. The class is basically just a template, and based on the class, you are able to what? Create an object out of the class. So if I give you a template right now that I need you to make something based on this template, then you know that, okay, this is what you gave me. I looked on it and I was able to manufacture this thing, this object that I'm holding. Then we have created an object. Now, let's get into it more. When we talk about classes, the first question you ask yourself, we've been doing fine with the programming that we've been doing so far, writing functions and procedural. And the question is, why do we even need to know object-oriented programming? Why are you introducing the concept of class? Can't we just stay with our functions and what have you that we've been using? Yes, you can equally create almost anything you want with your previous knowledge, but then you realize that when we start building bigger projects, it becomes a bit challenging working with a lot of data and functionalities. So what classes will enable us to do is, let us put together all related data and functionalities, couple them together into one thing, into a template, so that anytime somebody needs to create something like this, they will just follow suit. So based on what I've said, I've mentioned the fact that we are looking at some form of data and some form of what? Functionalities. So using classes enable us to put these together. The data and the functionalities enables us to put it together. If you look back to all the things we've discussed before, how we store data, like for instance, when we talked about variables, you realize that dictionaries, list, any of those things that we talked about, mostly it was just storing data. So we could easily store data in our variables, in our lists, in our dictionaries. But then when we start looking at these data combined with some form of behavior or functions, okay, functionalities as I'm referring to them, then it becomes difficult keeping these. So the concept of class is what is going to help us achieve that. And I'm going to explain this. But to get to that point, let's take any object at all and analyze what we mean by the data and the functionalities. If you take any object at all, so for instance, let's take this object. I hope you can all see this. I'm holding an object, right? I hope you can see it. So this is basically a pen. It's a what? A pen. The company that makes this pen has a template based on which they create the pen. So you realize that almost all their pens look the same. In fact, I think I have a couple of them. You see, they all look similar, if not the same. So what it means is that they created a class, which is the template for the pen. But then each of these pen can easily be identified from the other. How is that? Each pen has its set of properties, right? So that is referring to the data that we've been talking about. So one peculiar property about pens that I remember from school, back in school, is that each pen has like a unique number on it. They usually write it at the far end here. So let's say the pen's ID. It has an ID. But then aside this, if you create the pen with all of these things, what does the pen do? The pen is an object and it has what? Some form of functions or behaviors. Why do I say so? The pen we know is supposed to be used to what? To write. So if you end up creating a pen based on this template and your pen is not writing, then we are looking at something else. If I came up and I said that based on the template I've created this, it is a totally different thing altogether. But now our goal is, okay, this company has given me their templates in the form of the class. I'm supposed to create objects. The object that I'm creating is a pen. So I create pen 1, and pen 1 has some properties, it has some functions. Definitely when I create pen 2 too, pen 2 will have same. It has properties, it has functions. Like here, let's say this, it has a cap, it has this, it has that, the length of it, the shape, all of those things are properties that needs to be well noted. Okay, so in object-oriented programming terminologies, now we are coming into programming itself. In object-oriented programming terminologies, especially in Python, how we are going to identify these things are this set of data that we are referring to, the ID, the color of the pen, any other thing that it has, the length or height, all these things are referred to as attributes. So the properties, when you are dealing with Python, I have to be careful using the word properties. So these things, the data about the objects that you are seeing is called attributes. Okay, technically they are attributes. Then in object-oriented programming, these functions or behavior of the object that you are going to create are known as methods. So remember those two things, attributes, methods. So anytime you hear me say attributes, you know that I'm referring to some form of properties that each object that you are going to create, the object has, or the class stipulates those things. Okay, very important. The method refers to the functionality or the behavior that the object that we are going to create has, or behavior that is mentioned inside the blueprint, which is the class. That, okay, this object that you are going to create should be able to do A, B, C, D. Those ones are referred to as methods. Still, before we get into the actual code, there are one thing that I need to mention here. When we talk about attributes, there are two main types of attributes in object-oriented programming. So let's get that out of the way before we start. We have what we call the class attributes, and we have the instance attributes. So the class attribute basically refers to all those attributes that are common to every object that you are going to create out of the template, which is the class. Remember, it's called what? Class attributes. So these 3 pens that I'm holding, they were created from the same template. And there are some attributes that are similar across them, and there are some that are unique amongst them. So the unique ones are referred to as instance attributes. Basically, all that we are saying is that when we say an instance, that is like a single object created from the class. An instance is what? A single object created from the class. So if I say an instance attribute, then I'm referring to an attribute that is respect to that single object that is created from the class. I hope that makes sense. But then if we have an attribute that is common amongst all of them, like for instance, what color are all these pens? They are all blue. So assuming that this template that we're given to create the pens stipulated that color is equal to blue, we can call this color to be what? A class attribute. But then I also mentioned earlier that each pen has an ID attribute. So if you look at the far right, you see IDs. This is SL01. Then this is SL17. So let's take just those two. You realize that the IDs are not the same for all of these. One is SL01, one is SL17. So this tells us that this particular ID attribute is not the same across board. We don't copy it across, but then each of them can bear its own ID, hence making that what? An instance attribute. I hope we are understanding what is happening. So the things that I've defined so far, I've defined what a class is, I've defined what an object is, I've defined what an instance is, then I have also defined what a class attribute. In fact, I've defined what attributes are, and I've broken them down into class attributes and instance attributes. The process of creating an object from a class. When I say these things, in your mind, just see it like this. The process of creating something from the blueprint. Because a class is what? A blueprint that you were given, or the plan, or template. So you had a template based on which you should create something. And you go ahead and create an object out of it. That process of creating it, we are creating an instance of this class. Remember, I said the single object that you are creating is an instance. So you are creating an instance of that object. So the process is known as instantiation. So if I ask you to instantiate a class, all that I'm saying is create a single object of the class. So we have explained that term as well, instantiation. It just simply means create an instance of the class. If I say create an instance of the class, always remember the class is just a template, and you need to use what is presented on that template, assuming that it is a building you are going to build. The architect has put a plan on that template. By putting out the plan, the architect has not built the house, but you are going to pick the template or the plan and look at it and say, okay, this is what we need to model the house after. Okay, so this house has 3 bedrooms. It has 2 washrooms. It has this, it has that. Those are the attributes. Then in here, there is some, this house maybe, okay, so let me go. I'm trying to explain instantiation. So now that you have seen the template and you have seen everything that is on it, you now begin to build something out of it. Then you start digging the foundation, putting things in. Okay, so the foundation should take this form because in the plan that I was given, this is the number of houses or the number of buildings that are supposed to go in. That process of creating a single object out of the template is what we are referring to as instantiation. Any questions so far about the definitions? We are going to jump onto code right now. So any questions about these things? Yes. Okay. I believe there are no questions, and therefore I can move on. The last bit before I jump onto code, I nearly escaped it. So when you say a programming language is object-oriented, OOP, or obeys the OOP paradigm, okay, there are four major things that you need to consider to say that this language obeys object-oriented programming, or you have used object-oriented programming in your software that you developed. The development or the way that you approach your coding should obey some principles, if I can call them such. So there are four major principles, and some of them are a bit confusing, especially when you are totally new to this. I'm just going to make mention of them today. Then later we'll take them one after the other and work through them. But you just need to know so that if you are asked anywhere at all, you'll be able to answer that. So the four principles that your system, your coding should obey in order for us to say that you obeyed the object-oriented programming paradigm. Those four principles are: one is inheritance. When you look at it from an angle of an object, in fact, you can, real life objects, you can easily pick these things up. Then there is what we refer to as polymorphism. Then there is what we call encapsulation. Then finally, there is what we call abstraction. Encapsulation and abstraction usually go together. But then for now, don't even bother yourself about what they are. All you need to know for now is that, hey, the code that you are writing should obey these principles to an extent for you to say that you are doing OOP. That is object-oriented programming. So now let's see how we can create a class in Python, how we can instantiate an object from the class that we create, how we would be able to create class attributes, instance attributes, how we are going to differentiate the two, and the process of instantiation. At least let's appreciate these things. Then we can move on from there. Okay. If you have any questions, you can pause me and ask your questions. All right, so I'm using this editor, which is Replit, their online editor. And basically, let's start with something. What class do we create? We are working with a pen. So let's create a class that is going to be used to build these pens. Okay. The common name that I can see on this is Crystal. So let's just call our class Crystal. So basically, to create a class in Python, creating a class, you start with the keyword class. In a previous PLD session, I shared with you the reserved keywords in Python, and class is one of them. Like, Python understands what class is. So all you need to do is, when you want to create a class, remember, when I say class, I just mean you need to create a template based on which some other object will be created from. Okay? If you are a creator right now, irrespective of what you are doing, like, it's like a recipe. If let's say you're a caterer, you're going to cook, you create a recipe based on which you prepare your meals, right? In fact, almost everybody who cooks has a recipe that they use, whether they have it documented or not. Maybe they were taught in a way. So you are just coming to create that recipe that we are going to use to prepare this our pens. So the name of the class, it is recommended that the name begins with a capital letter. So we have the keyword class followed by the name of the class. So we call our class Crystal because that is what I can see written on all of them. Then in Python, you follow this with a colon, right? Then hit your enter key. Remember that indentation is so important in Python. So just by doing this, and we've already spoken about pass, the keyword pass. Pass is like, hey, I'm not ready to work on it right now, but I don't want you to throw me an error. So let me leave you there. So pass over me, like no errors. That's basically what it means. If I take this out, I currently will have an error. If anything, try to save this file and you're going to get an error. Okay, so I'm just putting pass here, and this is saying that, hey, I've created a class, except that a class doesn't do anything. You've created an empty class called Crystal. It doesn't do anything. It has no attributes. It has no methods. Okay, so now let's look at how are we going to create attributes. If you paid attention to what I did earlier, when I gave an example here, color as an attribute is equal to blue. You realize that in Python, writing color is equal to blue like this is basically creating a variable. So an attribute is basically creating a variable in classes. So when you use a variable in a class, it is known as an attribute. Remember, we had these terminologies, variables. So prior to doing OOP, we were using the term what? Variables for storing data. We're using another term called functions for representing a certain behavior or functionality. Now when we switch to object-oriented programming, we give them a new name. They are basically the same thing, but we are giving them a new name because they are in a new environment. So we begin to call the variables attributes, and we call the functions methods. So going forward, if you hear somebody say attributes, in your mind, just see it as, oh, variables in a class. If you hear somebody say method, in your mind, just hear it as what? Functions in a class. If you find it difficult to understand, this should clear those doubts. You know what variables are, you know what functions are. So when we are dealing with a class, this is how we refer to them. All right. So now let's create a class. Let's create a variable called color. Sorry, my indentation is important. So color, and it's equal to blue. Remember that I said in a class, we say this is what? An attribute. So here I've created an attribute. Very important. Now, let's create our first method, which is like a function outside there. So outside there, let's say we have a function that says, hey, the pen is supposed to do a couple of things. Let's say the first one is to write. So we want our pen to write, okay? So outside, if we are not dealing with object-oriented programming, how do you write a function? You write it with a def keyword followed by the name of the function. So let's say our function is called write. Then you follow it with this, right? The parenthesis with a column, then the content or exactly what you want your function to do. And this is pretty much similar. Remember that I said a function is just, a method is just a function, except that we are using it inside a class. Okay, so let me comment up here. This is an attribute. This is an attribute. This is a method. But then there is a peculiar thing that we need to appreciate when we are writing methods in Python. Whenever you are using a method, remember that the method is like the function that this pen can play, or the role this object can play, or this object's behavior. That is its method. Okay, so anytime you are going to call a method, it means that you would have created an object. You can't just go and use the template and call, hey, write. The template is not a pen. The template or the plan that the architect gave you is not a house. So if I've given you a plan for a swimming pool, you can't just jump into that plan and be swimming. But then when you have created a swimming pool out of that plan, you now have the right to jump into it towards swim. So there should be an object for you to be able to use the method. Therefore, anytime we are creating a method, we ensure that we pass an instance of that class to the method. Remember, an instance of the class, what did I say an instance of the class is? It's just an object that you create out of the class. Creating an object out of the class. That's an instance. So anytime I'm going to define this particular function, let's say our function that we wrote, write, as a parameter, I need to provide something that represents the instance, because I am now defining the class. I am yet to create an object from the class. I hope you understand the words and therefore I can use them as I am using them. That's why I took my time to explain them before coming here. To create a method, I need to pass like a placeholder for the instance of that class that I'll be using later. Remember that I said you are only going to be able to write if you had the pen. Now we are now defining it. We don't have the pen yet. So all I'm saying is that we need something here that will be used to represent the pen, even though we are yet to create it. So that as soon as we create it, we know that we have catered for it. And it's referring to this specific pen that we have created. That's the specific object that we have created. So in Python, the very first parameter that you provide inside your method is considered as the placeholder for that object. So anything that I go ahead and I write here will be considered as what? Something representing the object that I'm going to be creating. So that if I want to be doing anything at all on this particular object, I can use the parameter. Because this parameter is representing any object that I'm going to be creating out of this template. But by convention, we always represent that with self. Remember, I started from somewhere. I said anything you put there in the first position is likely to be used as a placeholder for the object. But the convention is self. So just so you save yourself time trying to figure out why you did what you did after some time, and saving others also time when they are reviewing your code, just stick to the convention, which is use the word self. So all that I've said is that to define it, I need to pass self in here. So that is like the only, will I say only, like the basic difference between your normal functions that you create and the methods you create inside a class. So inside a class, your method is going to be working based on a particular object that is created. So this pen can be used to write. So all that I'm saying is that now I'm defining what the pen, when it is created, can do. But then I may be doing things with it. So I am representing this pen that I'm here to create with the self keyword, and Python understands it. As soon as I put it there in the first position, as in the first parameter, Python understands that, hey, this is the pen that we are going to have. Okay, it's representing the pen that we are going to have. Any questions? Sorry, let me sip water. Okay, so now we can go ahead and do something to this pen that we are going to create. We need a pen. Okay, let's do the basic thing. We need a pen to write something. Okay, that's the write function. So we'll go ahead and say, what should they write? Let's say write, using a print statement, we'll say, hey, I am writing. Okay, so basically this method that we have created in our class, all that it does is write, hey, I am writing, because it's a write function. We needed to write something. Then we have created an attribute here. For now, let's see. This is basically a template that we have created, and all that it does is it helps us create a pen. It helps us create a pen, okay? And that pen has only two things. It has an attribute called color, and it has a method called write. So I can go and create, let's go and create, that is, now this class is done. Like, the template is done. I'm done defining the template. So let me close it up with something like this, just to show you that what I'm doing right now is not necessary, but just to show you that this is basically the template I was looking for. I've created a template. I'm done. So now, based on this template, I can go and create an object, which is the pen itself. This template is just telling me that anytime you need to create a pen, call a crystal pen, okay? Anytime you need to create a crystal pen, the pen has an attribute called color, and it's assigned to blue. And it has a method called write. And what it does is, hey, I'm writing, print, hey, I'm writing. So if we need to use it, the process instantiation, as I explained earlier, that is, we are going to be creating an instance of the class, okay? So say create an instance of the class. And the instance of the class is called what? It's called an object. You shouldn't get my network. Okay, so don't get confused with the terminologies. That's why I'm taking my time to break them down, because usually when you read tutorials or you watch videos, they tend to use them interchangeably, and if you don't know that this means this, you get confused. Okay, so basically I'm saying instantiation is the process of creating an instance of the class, and an instance of the class is known as an object. So if I say create an instance, it's the same as saying create an object. If I say instantiate it, it's the same as say, oh, create an object of this class. Basically, it's the same thing. So how do we do that? To be able to create an instance of the class, we need the name of the class. Okay, so our class here is called what? Crystal. Then you need parentheses. This is how we do that. But then the best thing to do is to assign this to a variable. We are creating an object. So this is our first pen that we are creating. We need to create this pen, which is an object of crystal, the crystal class. So we approach it this way and say first pen is equal to this. All that this means is that, hey, I've given you the template that this is how you create pens. Okay, go and start creating a pen. And you have just noted that, okay, based on this template, I have started creating my first pen. That's all this line is doing. Based on the templates that you were given, you started creating what? Your first pen. And since this template is already defined, all the attributes that were defined, all the methods that were defined, you have it inside this pen. So you've created a pen. That is all. Does that make sense? I hope it does to everyone. So now that we have this pen created, what it means is that this pen actually has the color blue automatically taken up. Like it automatic, because you created it from the template. You haven't changed anything yet. This is the template that you were given. Go and create a pen out of it. You've created a pen called first pen. So that pen automatically has what? The blue color. And it has what? The write method. So if I go ahead and I say how I'm going to access the method, okay? So first pen, I want first pen to write. This is first pen, I've created it. But then if I need it to write, I'll say dot. Then I'll bring the name of the method, which is write. Okay? As simple as that. The question here, I mean, this is all I need to do for this write method to work. The pen has been done already, and I know that this pen can write. It can write this. So anytime I need it to write, I'll just say dot write. Hey, you first pen, I've created you, but I need you to write. So first pen dot write. But the question you may have is, how is it that when we were doing this, put self in there? So why don't I go ahead and put self here? And that is a legitimate question. However, that is not what you are supposed to do. Reason being that, what did I say about self? Self represents the object that you are yet to create. When you were defining a class, you hadn't created an object yet. You were just preparing your code to know that you are going to eventually use this to create an object. And anytime you create an object, that object should have this method, write. And anything that you want to do in there, we'll see later how we are going to be able to work on the objects that we have in there. But we have, I mean, self is representing that object we are here to create. So as soon as we created this object, when we call write, which is the method on the object that we created, Python knows that automatically. I mean, you already told me that you would, whenever you are calling write, I need to use the object that you are going to create. And now you have created an object called first pen. So don't tell me again. Like, I know. Why do you have to even tell me again? You told me, that's why when you were defining it, you had to mention it. When you were defining me, you told me that anytime you are calling write as a method, it's going to take that object that is going to be created. So now you have created the object. So Python will automatically pick that object. You don't need to tell it. So that is all. Basically, that is all that we need to do. And this should work if we go ahead and run our code. Okay? So let's try running this code. Hey, I am writing. And this is coming from this particular line of code. Maybe I should get rid of the instance, then show you what will happen. So I told you that the template is just a template. It doesn't do anything. The same way the plan that the architect drew for you is not a house. The swimming pool plan they gave you is not a swimming pool. Until you create an object out of them, you can't use them. So if I go ahead and run this again, nothing is going to happen because this is just a template. We are yet to create anything out of it. Hi. Topzit. Hi, Topzit. If you aren't saying anything, then kindly mute. Okay. All right. So you see that even though I've run this, nothing is happening. And the only reason nothing is happening is because I only have a template. And the template is not an object. You have a plan. You haven't executed a plan. Nothing is there. So for us to do something, we need to execute it. But then this was a process of creating the object, right? What we have here, this line was just a process of creating the object. And by creating the object, we haven't really done anything. Like, we just created an object. So if we go ahead and run this, still nothing happens. But then when we now bring in the write method, which we define to do what? To print out something. That is the point in time where something will be printed, because now we are calling this specific method to print out something to our screen. I hope that makes sense. So if I go ahead and I run it, you now understand that the printing here is actually coming from this line of code, because when we commented it, nothing was printed to our screen. But then what happens when we are creating the object? We say we are instantiating the object. Okay, how? I mean, is okay. Before I go there, let me assess. So this is using the method. This is instantiating. The next line was using the method. Using method. So now let's try and assess the attributes in there. I think that's a very important one to do. Let's assess the attributes. So to assess the attributes, we will just go ahead and say first pen dot the attribute name, which is color. See, this is if you were doing your normal programming without object-oriented programming, to call a function, you would have called it without this. To call a variable, you would have done it without this. But so far as you are in object-oriented, it is in relation to an object. So that is why you have the object, then dot, whether the attribute name or the method that you are going to use. So this will not print anything to our screen because it's just a variable that we are calling. So if we want it printed out, we have to pass it to the print function. And the only reason why this particular printed something, even though we didn't explicitly call print on it, is because in its definition, we have a print statement. Okay, so now if I go ahead and I run this code, I should get, hey, I am writing, then blue. Reason being that I have called the method here and the method prints out something. Then I've printed the attribute color, and the attribute color was what? Blue. So that is how come I've gotten this. Now, one more thing to learn. When you create an object, okay, what goes on for this template to actually take effect and say that, okay, now you have created the object? There is like some processes run behind the scene to ensure that this object that you are creating has all the attributes that you need it to have, and it has access to all the methods that it needs to have access to. Okay, so one of such that we can have access to and control is a method, is a magic method that we can have. You define it with underscore underscore. Remember, I said underscore underscore, so double underscores. Init underscore underscore. Then your parenthesis, and remember, you need to pass self. Reason why you need to pass self is you need to create a placeholder for the objects that you are going to be creating out of this template. So what does this magic method do? So if you watch any tutorial anywhere and you hear magic methods in Python, they are just methods that have these double underscores before or and after them. Okay, and another name for them is dunder methods. So if you hear it anywhere, dunder methods or magic methods, they are just basically referring to a method that has the double underscore before and after. Okay, so such a method, what it does is that it initializes. Remember, when you are about to instantiate an object, that's the first thing that happens, the very first thing that automatically runs. So if you go ahead and state, like I can state exactly what I want it to do. So for instance, let's say I want it to print something. Anytime an object is created, I want it to say you just created an object. As simple as that. Because here, when we created the object, we didn't see anything. Okay, and as soon as we have defined the init dunder method, what has happened is that we have now said that anytime an object is instantiated, do this for us. So in here, we are saying that you should print, you just created an object anytime an object is created. So prior to having this line of code that we have now, if we had only this up to this place, so let me, here, you remember this is where we are creating the object, the first pen. If we have only this one and we run it, nothing happens. The reason being that we haven't called any method, we haven't printed any attributes. But then the moment I introduce this particular method, the dunder init method, the moment I introduce that, what I'm saying is that at the very point that you are creating the instance of this class, I want you to print out something to my screen. So now let's go ahead and run this code. And it says you just created an object. So how is that? This is coming from this line. That means that automatically when you do this, when you instantiate a class, those are the terminologies. But all that it means is that when you begin to use the class, the dunder init method is automatically run. So if you ever need to put in something such that anytime that a class is instantiated, that code should run, then you would look at putting that inside your init method. I hope that makes sense. I need to have it inside my init method, as simple as that. Okay, so now let's come to the concept of instance attributes and class attributes. I think we've done 56 minutes. That's interesting. Okay, so we've already stated an attribute up here. And this attribute, we were able to access this attribute with this print statement. Okay. Then let's create another instance of our class. Okay. Create another instance of our class down here. Call it second pen. Call it second pen, and it's the same format. So call crystal with a parenthesis. Now we've instantiated another class. Let's go ahead and print the color for second pen. So to print the color for second pen, we need to change this to second. Okay, good. So now when I run it, what do you think is going to happen? The first thing is this object will be created first. And when this object is being created, obviously our dunder init method will be called first. So we'll have, you just created an object printed to our screen. Then when we get to this line of code, we are going to print the color of the first. So I think let me edit it and say, use the F string and say color of first pen is, okay, copy this part, then I'll close this and put this inside the curly braces. Great. Then let's do the same for here. All that we are saying, just so that you see the difference. Okay. Great. So now what is going to happen is that we are going to have this instantiated and it will print, you just created an object. Oh, color of second pen. This should be second. Second. All right, so let's go ahead and run this. So the first thing it said was you just created an object. That was our first pen object. Then the second one is color of first pen is blue. The second line is, the next line is you just created an object. That's the second object that we created. It says color of second pen is blue. So you realize that both of them has the same or have the same color. The reason being that The reason being that we stated here color is equal to blue. And since the examples that I use, all the pens are blue, we are saying that we want every pen that will be created from this class to be a blue pen, or this template to be a blue pen. So in that instance, in that case, let me not use my English to come and confuse your programming. So in that case, this particular attribute can be referred to as a class attribute. This is because it is common to all of the instance that we are going to be creating. But then we also mentioned earlier that each of them has a unique ID. So now let's give each pen an ID. So that would help us hammer the concept of the instance attributes. Now we've seen what class attribute is, and usually you see the class attributes declared up here before your methods. Okay, that's what you usually find. Your class attributes will come before your methods. Now, to instantiate the attribute, remember that this init method is always run the very moment we are creating the pen. So what we can do, since each of them is supposed to have a unique ID, is that anytime we are about to create the pen, we are going to pass the ID of that specific pen we are about to create so that it can be assigned to it. Okay? Because it is unique, we can't just go ahead and write it once inside the template and every one of them will inherit that same ID. No. But the very time that, so I've told you, like, according to our template, there is a portion for ID. So anytime you are going to create a pen or an object, technically an object from the class, you need to provide this ID. So how do we do that? I can just go ahead and pass that as an attribute, a parameter to the init method. So let's call this ID. Okay. This ID, remember, is just a placeholder. It's a parameter. If you've learned your functions, you understand this. So that when we are calling it, we'll call it with this ID. However, how do we make sure that we have assigned that ID to the pen, the specific pen that is being created, or the specific object that is being created? If you recall, I said that self is put here so that it make reference to that object that you are going to be creating. So kindly give me a few seconds. Let me pick this call, please. Please give me like 1 minute, please. I beg. Hi, everyone. So sorry about that. Okay. Hey, this one I'm not hearing. I hope you can hear me. Hello? Hi. Can anyone hear me? Can anyone hear me? Hey. Hello? Can anyone hear me?
Yes, we can hear you.
Oh, okay, good. All right, thank you.
Yeah, we can hear you, sir. Sorry, I'm looking for a way to unmute myself so that I can tell you that we can hear you.
Oh, okay.
Welcome,
Okay,
sir.
thank you
Sir,
all.
we are enjoying what you
Yeah,
are taking up, sir.
welcome. All right. Great to hear. Unfortunately, I have to run away soon, so let's try to wrap up this session. Then we'll schedule another session to continue. Okay.
Yeah, I'm sorry.
So
Before you go, sir, can
yeah,
I ask you a
go
question,
ahead.
sir?
Go ahead.
This is my first time of joining your section, sir. And with this little time that I've
Oh,
spent
okay.
with your section, I can really testify that, like, you understand the concept of teaching a beginner. So my question is, can we just please, for the sake of we that we are beginner, like, be having this subsequently, sir, like continuously, because it's going to like help majority of us, especially somebody like me, like
Uh,
this.
yes. So we'll try our best, except that because of time issues, we've not been able to. I mean, previously we used to do like twice every week, but then anyway, let me hope that we'll be able to do as often as possible. Okay, but in any case, every information will be communicated in the group, so you don't have a problem. Just take a look at the group for any notification as such. Okay, so let's finalize that part where I was talking about I need this ID to be set anytime an object is created. But remember that I said that self here is placed there to represent the object that I'm going to be creating. Whenever I take this template, when I need to create an object out of it, everywhere I see self, it represents the object that I'm going to be creating. So that means that if I need to have this object to have an ID when I create it, that means I need to assign that ID to the self object, right? And if you can remember here, to be able to access, when I created the second pen object, to be able to access the color attribute, what did I do? I did second underscore pen dot color. And that means that I'm referring to the color attribute of second pen. So for each object that I'm going to create, remember self represents the object. So if I do self.id, what does it mean? Based on your knowledge from what I did earlier here, first underscore pen dot color meant that I'm referring to the color attribute of first pen. So if I come in here and I say self.id, all that it means is that I'm referring to the ID attribute of each object that I'm going to create. Any instance of this class that I create, I am referring to that particular instance, its attribute called ID. So I need to set this to a value. What do I set it to? I say this is equal to whatever ID that was passed here. Okay, so let me back up a bit and do this. If I did this and say the ID is just SL01, if I did this is good, but then what it's going to do is it's going to automatically set the ID for every object that I create to this particular ID. And remember that is not what we wanted to do. If we wanted all of them to have the same value, we could have just passed it as a class attribute. And I've explained what a class attribute is. and why we use a class attribute and why we use an instance attribute. Now we know that the IDs are unique, and we need to pass the IDs when we are creating the actual pen. So we are going to pass that ID anytime we are creating the pen by putting the argument or parameter in terms of the definition. So parameter in here. So now I can say this myself.id is equal to ID. A lot of people get confused thinking that this ID that they are seeing here is necessarily what you have put here. No. So I could have just said this is equal to number, then said this is equal to number. All that you need to appreciate here is that what does self represent? Self represents that specific object that you are going to create. So now if we come down here, we've created two objects. We've created first pen, we've created second pen. Okay, so by doing self.id, what we have done is that we have said that the first pen.id, we can actually get the ID of the first pen, any object at all, so far as we do the object's name.id, because we represented that with itself. Okay, and we can set it to anything that we want, but then we want people to be able to pass in the ID when they are creating it. Okay, so to be able to do that, we could use anything at all here, but just so your code makes sense to you and to other people who will review your code, it's best to use good identifiers. So good names that we can easily identify. That is why I started with using ID. Okay, so that is the difference. This .id is the attribute itself. This ID that I have here is the value that you are going to pass when you are creating it. So now that we have this, let's go ahead and do one thing here. When we stated that now it is not just the method, we need to pass what? A value, which is the ID. So what it means is that whenever you are instantiating the class, you need to pass this particular ID as an argument. So ideally, we should have passed self in here, but it doesn't make sense. I mean, the object in here, but it doesn't make sense. And like the initial implementation, I mean, the default implementation of Python is you can ignore the first argument because it always takes that first parameter as the object, and you know that you're about to create an object. So you forget about the first one. Any other one that follows, you have to provide it. So the ID that we are going to put here, let me say pass an ID is equal to, say, SL01. So this is for the first pen. Then for the second pen, I go ahead and I say ID is equal to SL0, is that 02? Okay, so let's make 01. Okay, so we are giving them the unique IDs, SL01 and SL02. So this time around, we can go ahead and print their IDs. Let's print this ID, say .id. Then do same with second pen as well. Say .id as well. If, let's say I change this to ID, then change this as well to ID. So if we go ahead and run this code, let's see what we get. It says you just created an object. That's for the first object. The color of your first pen is blue. ID of first pen is SL01. And you just created another object. Color of second pen is blue. ID of second pen is 02. So now we've made it such that you can easily assign like an attribute, unique attribute. You realize that for the color attribute is blue for both of them, and the reason is because that is a class attribute and it's similar for all of them, unless when we decide to explicitly go and change it outside. But then with the instance attribute, we use the Dunder or the magic method, the Dunder init method to set those ones. In fact, later we'll learn about some of the other ways that we can set these ones. But then there was one thing I was going to say. Yes. So what if I didn't include ID here? Am I going to get an error? And this, if you have done your functional programming well and you really understand it, you shouldn't have a problem understanding this. So whether you are using positional parameters or keyword parameters, they should all work fine. So I could run it without passing ID here, but I could also run it with ID if I'm using keyword argument. So all those things need to be checked. If you had any challenges understanding any of the things that we've done right now, I would advise that you go and revise your concept of methods, functions in particular, and I believe these things would make more sense. And if you missed any part, especially the beginning part when I explained the concept, you can always get back to the video when it's published and watch it, get the understanding. If you have any questions too, inside the group, you're allowed to ask your questions, or during our next session, you're allowed to ask your questions. Let me open the space for one question before we run away. One question. Then we can call it a day. So in summary, today we learned what a class is. In fact, I think I listed them earlier. Yes. So we learned what a class is. Now you should understand what an object is. When we say an instance of a class, you should understand what it is. You should understand what class attributes are, what instance attributes are. Then the process known as instantiation, you should also understand that. Then we've talked about the magic method init and the use of the keyword self as well. We've talked about the use of the keyword self. Then we also talked about assessing the attributes, assessing attributes and assessing methods. So in our next session, we'll go a bit deep, then make this more practical. Hopefully you understand this and it will become easier when we start. Any questions? 1, 2, 3, 4, and 5. Okay, so if in the absence of no questions, I want to appreciate you all for joining today's session. I really appreciate your time for staying with us throughout. And hopefully the next meeting will be announced in the group as and when it's going to come on. And I'll see you in the next meeting. Thank you. Bye-bye. Bye.